All are hearing my voice? No?
Hello, good morning,
All
sir.
are hearing my voice? Good morning. All are
Yes, sir.
hearing my voice?
Yes, sir.
Screen is visible?
Yes, visible, sir.
Okay, now we will go to the class. In the last class, we have seen terrace roof rainwater pipe size calculation and the channel line calculation. Remaining, we have to see roof gutter size calculation, drainage pipe size with Manning's and Williams formula, and the bill of material we will keep preparation method. Now we will go for roof gutter size calculation. For the roof gutter size calculation, you have to get the flow rate from the terrace area or roof area. So you have to measure the roof area. From the roof area only, you have to take the flow rate by using Q equal to CA divided by 360. The same formula only. You will get to some flow. After the calculation, you will get to the flow. To this flow only, you have to calculate the cutter size. Now we will go for the cutter size calculation. This is the rainwater roof. This is the house, one house. This is the roof, sloped roof. So in this roof, we have divided two areas. Left side one area, right side one area. You have to take that area only, not sloped area. Rectangular area only you have to take. In the plan only you have to take area, not in the elevation. So this is the gutter, rainwater gutter. Typically, both side we have to give. Otherwise, if it in the house one side slope means we have to give one side rainwater gutter only. After that, after the rainwater cutter, this will go into one pipe. This water will go into the rainwater pipe, this down type pipe. This down type will pipe will connect into the channel drain. That channel drain. So now we can see the rainwater gutter size. How we have to arrive the rainwater gutter size. So for the gutter size, this is the water level. This much water level we are considering. Width of the gutter, W is, this is the width of the gutter. Bottom outlet pipe is coming outlet pipe. This is the depth of the water. This much water, total depth of gutter. This is the total depth of the gutter. After the depth of the water, some of the depth we have to leave for pre-boarding. Then only the overflow will not happen. Otherwise, if you calculate exactly means the overflow will happen. More overflow happen. Should not be allowed. So that's why we have to put some idle depth for pre-boarding. So that's why we will put 60 mm, 100 mm. We'll put for according to the requirement. We'll put. This is the gutter section, typical gutter section nomenclature. You have to keep in mind this one. Now we will go for the question. rainwater gutter calculation. Discharge in gutter, liter per second. We have to convert the flow rate into liter. Already we have calculated meter cube per second. Already we have calculated all the flow rate in meter cube per second. The flow rate we have to convert into liter per second. Meter cube per second into liter per second.
Sir? Your voice is breaking, sir. We couldn't hear properly.
Now it is okay.
Okay, sir. Okay, sir.
Okay. You have to convert the flow rate into liter per second. This formula is will work for liter per second only. So that's why you have to convert your flow rate into liter per second. This formula is Q equal to roof area square meter into rainfall intensity meter per hour. Already we have put mm per hour. So you have to convert into meter per hour. That input into 1000 divided by 3600 into number of outlet. Number of outlet means bottom outlet already we have provided. Outlet pipe. How much outlet? One number or two number, three number. How much you want to put that out? Number of outlet only you have to. Roof area in square meter you have to put total roof area. One side, other left side, right side, both side is there in house. Left side, right side. You have to put. Now you are going to calculate. You assume right side only. Now you are going to calculate. You have to get to, from here to here. Vertical L and P you have to get. Not inclined. Hypotenuse you should not take. You have to take vertical length and vertical width and length only you have to take. Not hypotenuse. Okay, L and B you have to take. That area only you have to put into square meter. Rainfall intensity always available in mm per hour only. So you have to convert into meter per hour. Suppose you are getting 100 mm per hour means if you are converting into meter means 0.1 meter per hour it will come into 1000 divided by 3600 for conversion factor into number of outlet. You will get a liter per second answer only. Here you liter per second answer only you will get. So area of gutter, for the area of gutter, A equal to Q square into width of the gutter divided by 10,000 whole power 0.333. 0.33 you have to put into 10,000 for conversion factor. You will get the mm square. This area you will get the mm square only you will get area of the gutter. Depth of water in gutter. Depth of water in gutter D equal to area of the gutter. Area of the gutter divided by width of the gutter. Mm answer you will get. The depth of the water means this is the depth of the water. Here, water from the water level to bottom of the gutter. This is the depth of the water. Total depth means with the fluid boarding will be total depth will come. So total depth of the gutter TD equal to 2 into depth of the water. 2 times of depth. 2 times of depth. 2 into depth of the water plus fluid boarding. Fluid boarding 60 mm we have considered. Why 2 into depth of the water means already I told in the drainage pipe size we have to put 2 times of size only. That concept only here considered 2 times. Suppose more rainy is happen also that overflow will not happen. So that's why we consider 2 depth of the water, 2 times depth of the water. Here we put it, then we will get more size. So like that, this is there. This is the total depth formula. This is the schematic of rainwater drain. This is the cross section of the gutter. Already we have seen. For size of the rainwater outlet pipe, we have to get the outlet pipe size now. For that one, this is the formula. Size of the rainwater outlet pipe. Dia D equal to roof area in meter. roof area in meter into 1000 divided by 3.2 into number of outlet whole power of 0.4. This is the rainwater pipe outlet formula. For the content, different formula is that. That's why we have to go to that. The roof normal roof area already we have calculated. That is different formula. So don't use that formula here. Input now we are considered area of the roof. Assumed we are assumed 1200 meter. 1200 meter we are considered. Intensity of rainfall. We need meter per hour only. Already available intensity of rainfall is 100 mm per hour. We are converted into meter per hour, 0.1 meter per hour. Number of outlet I have considered two numbers. I have considered both side, left side one, right side one. In plan, we go plan. Left side, right side, we have considered both two outlets. We have considered. Assumed width of gutter. Width we have to first we have to assume. Then only we can calculate. Assumed width of gutter 300. I have assumed. So for the 1200 mm, I have assumed 300 only. If it is not okay, I have to go furthermore 400, 500. I have to go. Now I assumed 300. By the assumption only, you have to do first calculation. Step 1. How to calculate discharge Q equal to roof area in square meter into rainfall intensity meter per hour into 1000 divided by 3600 into number of outlets. Then LPS we will get. So 1200 our area intensity of rainfall 0.1 into 1000 divided by 3600 into 2. Number of outlet 2 we are considered that is 2 meter per second we will get. Now we are started means 16.667 LPS we are getting. So therefore 2 equal to 16.667 liter per second. This is the flow rate we are getting in this area. Area in this area roof area we are getting 16.667 rainfall flow rate we are getting. With this one we have to consider area of the gutter. Area of the gutter we have already we have assumed the width of the gutter 0.300 mm we are considered that only we have. So for the width of the gutter, area of the gutter Q square into width of the gutter divided by 10,000 whole power 0.333 into 10,000 mm only mm square only we will get. We are applying the flow rate into width of the gutter already we are assumed 300 divided by 10,000 whole power 0.333 into 10,000. So after we have solved, you will get 20,273 mm square. We will get. This is the area of the gutter. Gutter area we are getting. Gutter area means this one only. This area only we are getting. This is the gutter area we are getting. From this one, we will calculate other sizes. Depth of water. Next step, depth of water. D equal to area of the gutter divided by width of the gutter. Area of the gutter 20273 already we have calculated. 20273 mm square already calculated. We have calculated. We will divide by width. Width of the gutter 3,300 we have considered. After dividing this one, we will get the depth of the gutter 67.6 mm. We will get 67.6 mm. We will get total depth equal to formula already I told 2 times of water depth, 2 times of water depth plus free board 60 mm. So now we have to put the total depth equal to 2 into 67.6. 2D 67.6 plus 60 mm free boarding we have to put. After this solve 135.2 plus 60 equal to 195.2 mm. Total depth we are getting 190.2. So width of the gutter already we have assumed 300. Depth of the gutter is 195.2 we are getting. So size of the rainwater pipe. How to calculate size of the rainwater pipe for the gutter outlet? D equal to roof area in meter square into 1000 divided by 3.2 into number of outlet whole power of 0.4. You put this apply this all the data into this formula. 1200 into 1000, you have 3.2 into 2, 1 power of 0.4. So after this sort of this all the data, you will get to 128.58 mm. You will get 128.58. You will round it into 150 because as per the market pipe size availability, after 125, 125 means 5-inch pipe size. 5-inch pipe size. After the 125, you will get a 6-inch pipe only. 6-inch means 150 mm. If you go steel pipe means 150 mm will come. If you go plastic pipe means 160 mm will come. Now we are going steel pipe only for this cutter. So we are considering 150 mm. 128.58 mm is rounded into dia 150 mm as per market availability. So now gutter size is 300 mm wide. Already we are assumed that is okay. Into 1.95 mm depth. That we can round it into 200 also, no problem. 300 by 200. 300 wide into 200 depth. Two number of 150 outlet. Already two numbers of outlet only we have considered. For the two number outlet 150 we are rounded. So now 300 by 200 cut out with the outlet of 150 mm, two numbers. This is the gutter out pipe size. This is the output for the calculation. If you are putting more number of down-type pipe, the down-type pipe size will be reduced. Suppose you want to put more 3 number, 4 number means the down-type pipe 100 mm will come, 100 mm or 80 mm will come. If you want to put only one outlet, single outlet means the pipe size will increase 200, maybe 200 up to 50 something will come. So that's all. The same formula only. What is the roof area that we have to here? What is the roof area we have to arrive? Then intensity of rainfall. So all the data you have to assume. Without the gutter you have to assume. Suppose your roof area is more. If you are considering 3 mm, assume 300 mm wide means the depth will get more. The depth will not get more than the wide. So that you have to keep. Depth should be 2 by 3 size of the width. That concept is there. 2 by 3, 2 by 3 size of the width only should be there. That's why we have to adjust the width. So suppose you are achieving 300 wide, that the depth also coming 300, some 350 means you have to increase the width. Then you have to go 400. You have to achieve 400. Then you have to calculate. Suppose it is this answer is coming some 225 or 200 means you have to accept. Otherwise, if it is equal to 400 or lesser than some 390 is coming means you have to increase the size. Some 450 you have to assume. Then you have to calculate, you have to get. So like that is that. The width should be width of the drain, always width of the drain should be more larger than depth. That concept is there in the drainage. So that we have to keep in mind. This is the rainwater gutter pipe size calculation. In our commercial building or normal residential building, this gutter and all will not come. The older days means long back they have used gutters for the roof and all. Now we are not using this roof and all. Now we are going for RCC only, plot roof only. That's why this calculation and all will not come for you. This is rare calculation only. But anyway, you got to keep in mind. Suppose in any other one, any one of the projects it is coming like roof means you have to make this calculation. Then you have to give the input to civil department. Civil department will do the gutter work. The steel people, steel work, steel fabricator will do the gutter and all, gutter pipe size work and roof that and all they will do. For that one, you should not take any POQ or that and all. That will not come into your scope. You have to give the size and the length. That's all. width of the gutter, depth of the gutter, and the length of the gutter. Length of the gutter, you know, up to the plan, you can see the plan. In the plan, how much length you want, that you can put. Number of outlet, 1 or 2, 3, what you are considered, that only you have to give the input for input to the civil department. That's all. That is your work. Do you have any doubt in this rainwater gutter calculation? Okay, now we will go for other calculation. In the last class, we have seen stormwater drain channel drain calculation with the Manning's formula. With the Manning's formula, we have arrived at the stormwater drain calculation. So now we are going pipe size, the same flow rate with the pipe by piping network, not stormwater trench. Now we are going channel pipe drain with the intermediate pit, drain pit. So for that one, we have to get the pipe size. So for that one, we are going the Williams formula and Manning's formula. Both we are going the same formula only, but we are changing the shape. This rectangular shape into round shape, circular shape. That's all. So now we are going for this one, for the stormwater, for the trench drain, open trench drain, we have to use. Hello? சொல்லுங்க சார், நான் ஆன்லைன் கிளாஸ்ல இருக்கேன். சரிங்க சார், ஓகே சார். Minus formula that is using the same formula we are using for the pipe size calculation. That concept only we are seeing for that one. For the open drain, I have told already. For the open drain, we have to use Manning's formula only. For the closed pipe network, we can use both Manning's formula as well as Williams formula. Williams formula and Manning's formula both are same only. Some 5% variation will come. That 5% variation is allowed for our plumbing network. So both formula you can use for the pipe size calculation. Manning's formula you can use. Otherwise, if you are comfortable for Williams formula, that also you can use. Both are same only. But for the calculation, you have to use n value. Coefficient of surface roughness for separate. For Manning's formula means Manning's tabulation you have to use. Williams formula means Williams formula means Williams tabulation you got to use. That is the concept you got to keep in mind. So now we will go for the pipe size calculation with Manning's. Drainage pipe size calculation by using Williams equation. Williams pipe calculation we are using. Flow equal to same thing only. Flow equal Q equal to area into velocity. Flow Q equal to area into velocity. Velocity V equal to 0.849 c into R power 0.63 into S power 0.54 meter per second. You will get the answer. This is the Williams formula for the velocity. The velocity, if you are multiplying the area, means you will get the flow rate. That's the only we have to do. Flow Q equal to area into velocity. For the velocity, Manning's formula is 0.849 C into R for 0.63 into S for 0.54 meter per second. So for C means what?
Hello.
Hello?
The screen is not visible. It's in the rainwater calculation.
1 minute. I will check. Now it is visible?
Yes, sir.
Okay. Drain pipe size calculation by using Williams formula. Flow rate, you know, Q flow equal to area into velocity, you know already. For the velocity, the Manning's Williams formula 0.849 C into R power 0.63 into S power 0.54 meter per second you will get. This velocity, if you are multiplying area means you will get to flow rate. Therefore, Q equal to area into velocity formula equal to put 0.849 C into R power 0.63 into S power 0.54 meter cube per second you will get. So this you have to keep in mind. For the this is the concept is in this pipe we have to put air gap. You should not consider full pipe is running, full water is running like that. You should not consider. You have to put air gap in the pipe network. So then only your water will flow smoothly. Otherwise, backflow will happen. So how much you have to put maximum air gap 1/3 times of the pipe size you have to put the air gap 1/3. 2/3 times of the water you have to consider. Like that is there. If it is not there means you can this concept is not there means you can directly use in a circle formula. But if this concept is there, for that one you have to use this circles card formula like that. We have to use that and all. So that we have a theta equal to, for the theta we have to find theta equal to 2 cos inverse of r minus h divided by r. For the finding the theta, you have to use this formula. Area of the this area, vectored area, this dot blue color area is there, no? This blue color vectored area for this area, you have to use area equal to pi r square minus r square into theta minus sin theta divided by 2. So in this formula will work for radian. This theta you have to convert into radian, then you have to use not degree. You have to convert into uh, radian. Why I have given this radian formula means this formula you have to use in Excel. Excel sheet you are going to arrive this formula. So Excel sheet means Excel will work in radian only. So that's why I given this radian formula. We can put into Excel sheet, then it will work. And another one formula also is that with the theta you can put directly in degree. That formula you should not use because it will not work into Excel sheet. So that's why I given this formula. So I also use this formula only for arriving this flow rate and all. So then you have to, for this one you have to use pi r square minus r square into theta minus sin theta divided by 2. This formula only you have to use. Perimeter vector, for the vector perimeter, red color line is there. No? This is the vector perimeter. For the vector perimeter, P equal to 2 by r into 1 minus theta by 360. This theta is normal degree only. You have to put degree divided by theta degree. You have to put to 360. 360 you have to put to, then you will get the vector perimeter. You will get with this only we will get the data for the flow rate calculation. The where Q equal to discharge of the flow, discharge or flow in meter cube per second, you will get A equal to area of the pipe area of the pipe cross section in meter square. V equal to velocity in meter per second. R equal to hydraulic radius, area divided by perimeter. Cross sectional area divided by perimeter. You will get in meter answer only. S equal to slope, drop by run. Slope formula you know, 1 is to 300 means 1 divided by 300 like that. 1 is to 400 means 1 divided by 400. That only you put drop by run. C equal to Williams coefficient. Williams coefficient table is there. From the table only we will put to that Williams coefficient. I will show that Williams coefficient. This is the Williams coefficient of surface roughness. For the aspect of cement pipe 140, brass 132 for 140, brick like that. For every material of the surface, they are given that coefficient. From this table only you have to put what the material you are using, what type of pipe you are using. Suppose you are using plastic pipe means you have to use 140 to 150. 140 means for the older pipe, older material you have to use 140. Newly purchased pipe means you have to put to 150. So that is the concept. You have to take the C value from this table. Williams coefficient of different pipe types. As an Williams coefficient of different type of pipes. For the Manning's roughness coefficient, you have to take the Manning's tabulation. This is the Manning's tabulation. You have to take the roughness value for the Manning's formulation. You have to take this formula, Manning's formula, that coefficient of runoff is mentioned in N letter. N letter we have mentioned in the Williams formula. That roughness value is mentioned in C letter, C value. Like that is there, you have to take from the table or the calculation. So for P equal to vector perimeter in meter, theta equal to radian per area. Theta equal to radian per area. Radian you have to convert the degree into the radian. Then you have to put into area formula, and the theta equal to degree in perimeter. While finding the degree perimeter, you have to put it directly in degree only, that theta value. So now what are the input we are considering? Dia of the pipe equal to 350 I am considering. Now we have to, we are not getting directly pipe size in this formula. We have to get all the pipe size in the market pipe size for the from the 75 mm to some 600 mm. You have to calculate. You have to calculate. You put into one tabulation. Then you can easily make the pipe size in the drawing. With the flow slope, everything, this formula you have to put into the Excel sheet. You have to get all the pipe size flow rate with the slope, how much is slope, everything you have to put into Excel sheet. Then you can apply that data into the your layout. So like that you have to, you can't get directly pipe size from the flow rate. So now we are getting flow rate for the pipe size only. I am considered 0.35 mm, 350 mm pipe size only. I am considered for this calculation. You can do for a 75 mm to large size. How much size you are going to use for your project? That much you have to put first. Once you are arrived in the formula into the Excel means, so all the calculations easy for you. One single line only. Now I will show how I have arrived, that I will show after this calculation. After this calculation, I will show how I have arrived at. Just the same thing only you can also put into your Excel sheet and you can use for the project. Dia of the pipe 350 mm, 350 mm or 350 mm or 0.35 meter I consider. As an Williams roughness coefficient. Roughness of coefficient for plastic pipe I have considered 150 V by 2. Ratio of depth flow in the pipe cross section 2/3 I consider. 2/3, 2/3 of pipe only will get to flow like that I have considered. Means 2/3 means 0.6 mm only. Pipe slope I have considered 1:300 only. I have considered 1/300 or 1:300, both are same only. That only I consider. So that value is 0.0023 is will come. So now you will go for the calculation. The above data is I only considered. So R equal to D by 2. Dia divided by 2 is the R. So 0.35 divided by 2 is equal to 0.175. Radius is the 0.175 meter you will get. All the calculation with meter unit only, not mm unit. Now you will get the H equal to D minus D into ratio of depth flow. 0.35 is the D minus D into 2/3. 2/3 third of the flow only I am running. I am considered 2/3. If your multiple means you will get 0.223. You will get both your solve means H value you will get 0.1167 meter only. This much of height of the water only will flow into the pipe. Not flow. This is H value, not air gap value only. So this much height of the gap you have to arrive for the air vent. Depth means depth flow, water flow is the depth. H means air gap. So 0.1167 meter air gap height we have to put. So this is the H value. H value is air gap value. Water level is this much is going. Water level is the depth. H is the air gap. Air gap depth is the air gap height is the H value. So like that you have to put step 2. In this step 2 you have to get the theta. For the theta formula 2 into cos inverse of 1 R minus H divided by R. This if you are putting this formula, R value already you know 0.172. Minus H value we know 0.1167 divided by R 0.17 by I have put here. After this thing, you will get 2 cos inverse of 1 0.33 you will get. Cos inverse of 1 if you are putting 0.33 means you will get 70 degree, 70.2 into 70.52 degree you will get. So if you multiply into 2 means 141.05 degree you will get. This is the degree value. After the conversion of radian, theta equal to 2.46 radian you will get. For the area of the flow you have to use this one. Step 3 area A equal to pi r square minus r square into theta minus sin theta divided by 2. If you apply this in this one into pi r means 0.17 meter square minus r square. You have to put theta value in the radian. Sin 2.46 radian. Sin 2.46 radian divided by 2. So you will get the answer like this only. In your calculator, you can't get the radian value. For this one, you will get in this calculator degree. If you put the degree input means you will get the radian value. You will not get. That's why if you are calculating by this calculator means you have to put 141 degree for the sin theta. Sin 141 degree you have to put. From this one, this is the radian value. So after putting this sign to 141, you will get 0.6286. You will get. If you are arriving in the Excel sheet means you can put it directly sign to 246. This you can directly use the radian formula. So after you solving all this one, you will get 0.0679 meter square. You will get the area of the cross section area. Cross section area of the pipe flow area is 0.067 meter square. You will get. After this one, vector perimeter we have to calculate. Vector perimeter P equal to 2 pi r into 1 minus theta by theta degree divided by 360. Here you have to use degree only. 2 pi into radius 0.175 into 1 minus 141.05 degree divided by 360. So if you are solving this one means perimeter you will get to 0.6687 meter. You will get the perimeter of the vector perimeter. Vector perimeter you will get this pipe area. Now we have to calculate the hydraulic radius, area divided by perimeter, vectored area divided by perimeter. Hydraulic radius R equal to vectored area divided by perimeter. Therefore, R equal to vectored area already calculated 0.0679 we are already calculated divided by 0.6687 perimeter. If you are putting means 0.1015 meter you will get. This is hydraulic radius. Step 6 we are going means velocity. Velocity V equal to, now we are using that Williams formula 0.849 C into R4 0.63 into S4 0.54. Therefore V equal to 0.849 into 150. C value is 150 I have considered into that R value power 0.63 into S value slope. S equal to slope already 1 is 300 I can consider that value 1 divided by 300 only 0.0033 divided by 0.5 whole power 0.54. After solving this one we will get to 1.377. 1.377 means meter per second. 1.377 meter per second is the acceptable velocity because minimum self cleaning velocity is 0.75 meter per second. That you have to keep in mind. If you are putting this formula after you are getting lesser than 0.75 meter per second means you have to increase the velocity. How you are going to increase the velocity means you have to change the slope. Slope you have to change. Then you will get more velocity. One is suppose you are now we are giving 1:300 slope means you are getting 1.377 meter per second. If you are changing the slope 1 is to 600, assume if you are putting this formula for 1 is to 600 means your velocity will meter per second will reduce. Maybe you will get to 0.6 meter per second velocity, maybe you will get. That is not acceptable. So you have to calculate for the minimum velocity of 0.75 meter per second. So it should not exceed 2 meter per second for the drainage pipe test. Maximum 2 meter is recommended for the plastic pipe and all, underground pipe and all. We are considering more velocity more than 2 meter means that pipe you will get curved quickly, that joint and everything will get damaged. So maximum 2 meter you will get for the underground drainage and all. So more than 2 meter you should not go. In the hill station, if you are going to use, calculate for the Bangalore project or some other hill station project, means you will get more velocity only because your site itself will get more slope. More slope will come because that is hill station. So you will get more slope. That area you will get more velocity. In our Chennai project, normal Hyderabad or other area, Coimbatore, some area means normal slope only will. So normal some average slope 1 meter or 1.5 meter only will get. Just on the site to slope ratio only we will put it. So now we are getting V equal to 1.337 meter per second. So now we discharge. Now we are going other step. Discharge Q equal to area and velocity. Area already we have calculated 0.067 into our velocity is 1.377. We are short of means Q equal to 0.09349 meter cube per second we are getting. So now for the dia 0.350 meter pipe PVC pipe will take 0.09349 meter cube per second flow at 1:300 slope. This is your answer. So with this one you can what the so meter already you have calculated for some flow with the rainwater formula or some other input. Suppose this pipe is you are going to use for the industrial some other area, they will give some flow rate. Suppose you are assume you are going to calculate for the Coca-Cola factory. Coca-Cola factory building you are calculating or drainage pipe. In this Coca-Cola factory, lot of equipment is there. Lot of equipment they are used for the making the juice or Coca-Cola or the water, Kenley water also they only producing. For that one, they have more lot of equipments to make water filling, water purifying, juice making, or the pulp making, pulp filtering, everything is there. For the every equipment, they have some drainage flow rate. They will give for you for calculating the pipe size, drainage pipe size and trench pipe size and all. In that case, you don't calculate separate calculation for the flow rate and all. You can take the client inputs. Client will give the flow rate for the all equipment. From the equipment flow rate only you have to take for the pipe size calculation. So for that one you can use this formula, manage formula for taking the pipe size calculation. So you have to compare the flow rate with their flow rate. Suppose they are giving 0.08 meter cube per second flow rate for the equipment means you have to calculate this. You have to compare. So little bit exceed 0.808 mean. Now we are calculating 0.093 meter cube. So almost equal only, little bit only it is extra. So you can use 350 mm pipe size with the flow 1:300 for the 0.8 flow rate, 0.08 flow rate you can use. Like that you have to compare and you have to put the pipe size. For the every equipment, for the every area they will give flow rate. With the flow rate only you have to put how much flow rate it is coming. Like that you have to put in the sketch. Then you have to calculate in the Excel sheet. From the Excel sheet you have to put the pipe size. This is the slope, all the slope you have to put. Once you are calculating the Excel sheet means it for you very easy to put the prices and all. So now we are calculated the flow rate, pipe flow rate with the Manning's formula. This is the Manning's formula. Same thing, same formula for the same method for the Manning's formula also. Same formula only we will use, but velocity, this formula only is different. Verifying the calculation by using the Manning's equation. Manning's equation means he already has seen this Manning's formula for the rainwater trench drain calculation. That rainwater trench drain calculation, not only rainwater trench drain, if you are calculating some other trench also, you can use this formula. All the type of trench drain calculation, you can use the Manning's formula. And all the type of pipe size calculation, you can use Williams formula as well as Manning's formula. But the shape of the that surface only will differ. For the flow Q equal to area and velocity meter cube per second only. Velocity V equal to R power 2 by 3 into S power 1 by 2 divided by N. This N is the coefficient of surface roughness. You have to take the value from the Manning's table. For the plastic pipe, N equal to 0.009. This value only for the plastic pipe. Then Q equal to area into velocity. A into R power 2 by 3 into S power 1 by 2 only. This formula only we have to use for the calculate the velocity, pipe velocity and the flow rate. So everything I calculated R value, P value, and area, everything here we have calculated, theta, everything here calculated. From here we have to take and put. Then we will compare how the value is coming. Velocity V equal to velocity already we have calculated how much velocity 0.11015 by 3 power 2 by 3 into slope S equal to 1 is to 300 already I have considered. So for the 1 is to 300 0.0033 will come to the power of half 1 by 2 divided by N value is 0.009. If you solve in this one 1.39 meter per second velocity you will get. Velocity you will get 1.039. After you going this flow rate, flow Q equal to area into velocity. Area you know already you have calculated. But same the 355 size 0.067 meter square into velocity 1.39. If you put to means Q equal to 0.0943 you will get. As per Manning's equation for the pipe size 0.35 meter dia, will take 0.9093943 meter cube per second flow at 1 is to 300 slope with velocity of 1.39. Now we can compare both answer. As per Williams equation, how we will get a V equal velocity equal to 1.377 only. As per Manning equation, how much velocity I get 1.39. Both are almost equal only. If you rounded into this one means 1.38 is coming here 1.39 will come. Some 0.01 only variation will come. So almost both are same only. Some 5% variation are some. Both you can use for calculating the underground pipe size. For the drainage pipe size, gravity pipe size, you can use both the formula you can use. Then if you go the flow rate, how it is the flow rate? Q equal to 0.04349 meter cube per second. Q is coming with the Williams formula. If you give Manning's equation means Q equal to 0.04943 you will get. This is also some lesser variation only, some 5% only. So both you can use, no problem. So this is the calculation method of pipe size. Now I will show how I have arrived in the formula into the Excel sheet. Now I will show the one. This is the drainage pipe size calculation with the Williams formula. This is the pipe tag number. Each pipe I have put a tag. Required drain flow, cubic meter per second. I have put Williams roughness. I have considered 140. Ratio of the depth flow. I have considered 2/3 only. That only it is coming 0.66. It is coming. Proposed pipe dia. I have proposed 0.45 pipe size. I have proposed slope. Slope is I have how much I have 1/200 only I have put here 1/200 1:2 I have put slope here. Dia radian theta radian equal to how much theta I will get. This formula I have applied here. This already I applied this formula here. You will get the 2.46 radian only. You will get theta. Flow area of the pipe cubic meter. How much flow cubic meter you will get? Cubic meter per second you will get. Cubic meter per second, 0.113 cubic meter per second. Wetted perimeter. For this also I have formula. All the blue color letter, for all the blue color letter, I have put the formula. This is the number of pipe one. For this also I have put formula only. So all the blue color test I have put the formula only. So in velocity I will get 1.89 velocity I will get. So quantity of the flow. Square meter. Area I can flow area of the pipe in square meter. Okay, this is in meter square. Wetted perimeter. This is the wetted perimeter in meter. Hydraulic radius R equal to area by perimeter. You will get the velocity 1.89. You will get two quantity of flow equal to cubic meter per second 0.213. Flow you will get a number of pipe required one number. So if you put one number of pipe into 450 mm dia means you will get this much pipe size. This much flow rate you will get 0.213. Now if I am changing this, my required flow is you are seeing 1.1 meter cubic meter per second. So same ratio only. If you are changing this are the same. If you are putting here some 0.3 slope, I am giving more slope means how much it is coming. More slope I am getting. 1:100 I am putting. You can see now velocity will change. 2.128 it is coming. I not required 2.1. 2.128 I not required. I need lesser than 2 meter means you got increase 1:150 increase. How much slope is coming? 1.7 is coming. 1.7 is coming. It is acceptable. So then you can fix 1:150 you can fix. So all things it is coming. If you are putting, my calculation is telling if you are putting dia 300 with the flow rate, with the slope 150 means how much pipe is required? 2 pipe is required. So I need one pipe calculation only. So 2 pipe I should not put. Then what I have to do here? I have to change the pipe size. I will change 350. 0.35 meter I will change. Now it is coming. Now answer is one pipe is there. As per calculation, my requirement is 1 cubic meter of flow only. One cubic meter per second of flow only I required. But our pipe size will take how much will take? 1.128 will take with the velocity. How much velocity? This is the velocity. 1.884 velocity. Number of pipe is 1. If the slope is 1 by 150, 1 is 50, this is the slope. So if you are putting all this one into the table Excel sheet means you will get easily answer. For the rectangular drain also I have put like this only, same formula I have put here. If you changing this all the things, you will get to for the rectangular top flow as per requirement. This is the flow as per requirement. My requirement is this one. This is the breadth. I have put 450 mm I have used. Final depth is depth I have put. Depth will calculate by formula only. Depth formula 1 C by 2 divided by 150 I have put this one. If I put 450 mm means depth will become 0.3. If I change I am changing it to 600.6 means, so our depth will come, final depth will come 0.4. Slope I consider 1:200. You can also change our 300 velocity in there. If I change 1:300 means the velocity also will get changed. If I am changing 1:500 slope, velocity also change it. 1.15 it change it. Flow rate also it is changing. So like that is that. So man is coefficient I have put for this channel drain. In concrete only we are using, for the concrete 0.012 will come. So that only I have applied. This is the formula, all the formula I have put. You will get this flow rate, final flow rate you will get. So now you can compare. So my required flow is 0.91. What is the output is coming? My requirement is 0.091. My output is 0.061. It will not okay. Then what I have to change? Here I have to change with 400. I will change. Now I will get 350. So now I will get almost equal here. So 0.091 here I will get 0.104. So almost equal only. This you can use for this. This size you can use for 0.091 flow rate. So 350 wide, 200 depth. 350 into 200 depth. Slope for the slope 200. If you are increasing the slopes, velocity will increase. Now we put 250. Our velocity also will change. Flow rate also will change. So it is almost equal only this one. Our requirement and calculation rate both are same only. So now we get 350 mm pipe size with the slope of 1:250. Velocity is 1.135 meter and the output flow rate is 0.093. So now you can calculate like this to access it. The same thing also you can use same way. You can also use the rainwater formula also. You can use in the Excel sheet. How much area is the terrace area? You can use this and all. So all the things you got to put into Excel sheet. All the formula you got to put into Excel sheet. Then you will get. Do you have any doubt in the Williams and the Manning formula calculation? Hello, all are hearing?
Sir, no doubt, sir.
Are you understand this calculation now?
Sir,
Okay. Now Now you will take some 10 to 15 minutes break. After we will see the BOQ, how to prepare the BOQ and all I will explain.
Okay.
Okay.
Yes, sir, you can start.
Okay. Okay. Now we'll see the BOQ format. This is a typical format. This one project, previous project I have shared with you. Prestige Central Mall at Mysore project. Enough quantity for water supply and sanitary installation work. For all the BOQs, we have put notes and consider what we have considered, what we have not considered, exclusion, everything we will put in the notes. First page of the BOQ only we will put. This notes all works to be carried out to relevant specification as enumerated else where in the tender and as per the latest IS specification. All the chasing in wall for GA pipe shall be carried out by electric chasing machine. Any work to be done in RCC wall, slab and beam shall be done by the core cutting machine in consultation with the structural consultant. Pump and sanitary fixtures may be supplied by the client owners and the rate for the fixing will be as quoted by the vendor for the fixing only. The supply rate for sanitary and the CP fixtures is not to be the same may vary with respect to the model as mentioned. However, the rate quoted for the fixing will not vary. Vendor to quote for both supply and installation for the sanitary fixtures. Tender will be finalized taking into consideration quoted value of capital work, 5 years AMC cost. The cutout made by the plumbing contractor shall be finished in all respective, including waterproof. So like that, we have to put some notes what we have to do, what the contractor will do, what the client will do, what you are considered, everything we have to put into notes. So all the notes should come in front of the first page only. It should come. It should not be come into last page, because if you put these notes into the last page means the BFQ will not get clear. They will not get understand. So first you have to put consideration and negotiation. All the things you have to put into first page only. So if all the BOQ will have a serial number, description, unit, quantity, rate, total. So another type of BOQ is that without rate also, no rate, only quantity. Only quantity, no rate also is there. With rate also is there. With rate only we will quote. Sometimes without rate we will put. Rate column we will not put any value. We will float into the vendor. The vendor will put rate. So that also is there. So we will float into the description. We will put the without rate. We will float tender. After the floating tender, the vendor will put rate. The vendor will quote the tender. We will compare. We will compare some 10 vendor who is put correct value, who is considered all the specification. Everything we will compare. Based on that only, we will finalize the vendor. Then we will find increase the negotiation. After the negotiation, we will increase the rate. We will increase the we will launch the project. Like that is the project, one type of things. So this is the rough value. What we have put here rate, no, this is not the exact value. Against this rate only the vendor will quote. If I put total 21,000, the vendor will put some extra or reduction. Instead of 2.1 lakh we put here, 2.1 lakh we put. Instead of 2.1 lakh, the vendor may quote for 2 lakh or 2.2 lakh, 2.2 or 2.3 lakh. They will quote based on their cost. And this is the calculation only. We have to this rate, all the rates, consider what they have mentioned. The rate will put approximate cost only. The vendor only will put the exact cost based on their manpower and their material cost. They will put based on that calculation. They will quote against our estimation. So we have to finance. If you are working in the consultant, you have to compare all the vendor then you have to recommend the vendor for client. Client only please. Suppose you are floating the tender for contractor. Contractor will quote their rate. After you got to finalize 3 or 4 vendor, good vendor, you have to finalize. You recommend the vendor to client. Client will please. Client will negotiate the price and everything. After the negotiation, client will please the vendor. So like that process, a lot of process is there. So anyway, you have to know the format of the BOQ, how to take the quantity and all. You have to know. Based on the phone, you have to. Sanitary first part 1. You have to make part 1, part 2, like that you have to classify. Sanitary fixture, in this POK, we have started sanitary fixture separate. Sanitary fixture separate. And soil waste vent, drain waste water part in this part 2, soil waste vent and rainwater pipes we have separated. So internal water supply system we have internal and external we have separated. The base one, the storm water drain. is separated. Everything is separate parts here. The external water supply. This is the external means other than building. Outside of building, what are the things is coming? That only we have to separate. Because this, if you put a separate means the contractor they will select separately. Or the external stormwater drainage, they have put separately. External stormwater drainage means separate contractor. This is civil contractor will do the external stormwater drainage and all. So that's why we put separate. So like that we have to put. You see, this is the sanitary picture. In this sanitary picture, what are the sanitary picture we are using in the bathroom? That only we are putting here. For example, supply, we have to start the supply, installation, and the testing and commissioning of white glazed water wall hung. Wall hung means wall mounted. Wall hung installed. Supply installing, testing, and the commissioning of white glazed wall hung constellation European water closet with metropole concealed flush wall with necessary vent, check nut, stop cock, etc. Color solid sheet and cover with polythene buffer and flap, CP flanges, CP bolts and nuts, a pair of CHR bracket with nut and bolt, wall branches, etc. complete. So for the mounting and fixing of wall hung European water closet, what are the things they have to put? Everything we have put necessary bend, check nut, stop pack, solid sheet cover with polythene buffer and flap, chrome plate. CP means chrome plated. CP means chrome plated flanges, chrome plated bolt and nuts, and a pair of CHN cast iron. CA means cast iron chair bracket for fixing the wall hanging with the nuts, bolts, everything we have to include it. So this is the Volcan European description. This is the description. European water closet description. How much number we have used in the project? 15 numbers we have used. Rate per unit, rate per unit 14,000. So 15 to 14, 21 lakh. So 2.1 lakh it is coming. So like that we have to map the description. We have to put quantity, rough value, rough rate. Otherwise, you have to get you don't have rate means you have to get quotation from the vendor based on the vendor you have to put this rate. And the supply, fixing, testing, and the commissioning of white color Indian water closet, white color Indian IWC Orissa pen with the P drop or S drop with a metropole consider plus one. The necessary bandage, stop pack, etc. Like this is the Indian water closet. This is wall hanging European water closet. This is Indian water closet. Set numbers 5,000 for installation and fixing everything. So totally 30,000 it is like that. And supply installation testing and commission white waste wash basin. This is a wash basin, oval type wash basin. Below counter, what type? That is below counter, under counter. Already we have put the type also. What type? This European water closet wall hanging. This is Indian water closet Orissa pan. Here wash basin, what type of wash? Oval wash basin, below counter, everything you necessary sensor type, with the sensor not operating type, manual operating type, automatic operating type this one is. With the pop-up waste coupling, 30 mm dia CP bond, chromium bond, chromium plated bond, drop with the extension pipe to supporting bracket with the necessary steel support. Basing one number of 15 mm CP angle wall with 450 mm long CP connection pipe and CP wall punch, all the approved metrics are complete. Like that, we are given everything we are giving one description. So, based on this requirement, we have to put the quantity and the rate and everything. So, like that only, we have to put all the. If you go this urinal, supply, installation, testing, and commissioning of This urinal, all the necessary things you have to everything you have to put. So like this, you get all the put see, toilet paper holder, health parcel, cooking health parcel, towel ring, tin cook pot, electric hand dryer for the electric hand dryer. How the description is there. And the supply inside this now CP Bibcock. Bibcock means that tap 15 mm CPB chrome plated Bibcock. SS liquid soap dispenser. Soap dispenser, but in toilet will be there. That quantity, how much is there? Urinal partition. Urinal partition. In between the urinal, the partition will be there. So that partition, number of partition. And the supply international system with mirror. Different that above the wash basin, we have to put mirror also. That quantity also here. That description also here given. For that one, all the plywood, foam bracket, 20 mm design teak wood frame, and the mirror shall be fixed with silicon sealant, silicon sealant, fixed with nailed screws, etc. Complete. So 20 numbers they have put for the each 1020. Because like that we have to sorry. These are the things. These are the sanitary items, sanitary pictures. Sanitary picture you have to fix in the toilet. That you have to put like that. After going this, after putting this one, soil waste went under rainwater pipes. Pipe quantity separate you have to put. For the pipe supply fixing and testing of PVC soil waste pipe. PVC soil waste. Actually, PVC not there. UPVC only. We are UPVC soil waste pipe. That grade is SWR only. SWR means UPVC only. Wrongly put to PVC. Conforming to IS 13952. The pipe conforming to IS 9. The standard is IS 13592 1992. Type B with the rubber ring. The pipe the joint is using rubber ring joint. The pipe type is B type. B type with the rubber ring joint conforming to IS 5382. Joints inclusive of all necessary vessel legs, bend, T, offset, door, junction, cowl, etc. Laid underfloor or fishing in the ball and pipe inside the shaft also. Pipe in shaft, etc. Complete. For all the cases, you have to put like that. This is the description of pipe standard of the pipe. This is highest standard. Joint for the joint highest standard, everything we have provided. So pipe size here by A 70 mm, B 110 mm, C 160 mm. So running meter A 120 meter, B is 240 meter. So 160. So the quantity is not there. So that's the they put to rate. There is no quantity used in this area, so that's why they put rate only they put. Suppose this quantity is coming into this means they have to use this rate. So that's why we have to R like that they put. So for the PVC pressure supply fixing and testing of PVC pressure pipe. This is non-pressure pipe. This here we have non-pressure pipe because we are using severe application. That grade is non-pressure pipe. Here we are using some pressure pipe also for drainage, for connecting the wash basin and urinal and all. For vertical pipe, we are using pressure pipe also. For the full separate, we are considered. Supply fixing, testing, and PVC pressure pipe 6 kg per square centimeter. Conforming it to IS 4985. 200 for waste connection for wash basin, kitchen sink, to floor solvent cement sand, inclusion of putting laid under floor concealed with the wall, etc. Like that, we have put the size also 40 and 50 mm. We are used to that running meter also we have to put. And the rain for the rainwater pipe separate PVC rainwater and winter pipe SWR grade conforming to IS 13592 1992 type A. Type A we are using. Here type B we have put for the soil. The soil waste went to this soil pipe we are putting type B. For this rainwater pipe we are using type A. rainwater and wind pipe we are using type A. So like that is there. For this, the start is from 63 mm to 250 mm we are using. For all the quantities we have put on the rate everything here. There is no quantity means we are putting RO like that. Just rate only we are putting. So after that, the vendor will, based on the site requirement, the vendor will use the pipe, 60 mm pipe will use. If they using means here they will put quantity, based on the quantity the rate will come. This is a leaf drop with leaf drop with Kura. This is flow drop. MS slatted iron bracket, hangers, everything we have to separate. The deep fill feed drop, for the deep fill feed drop now separately we have put. For urinals, the deep seal flow drop we are using for the urinals. That quantity also we are put. This is applied fixing and testing of PVC flow drop for the shower area and another toilet area you are using. For that quantity also we are putting. So everything these are the soil waste vent and rainwater pipe items we have put. And this above are the drainage items. Now we are going for the internal water supply item. Water supply item internal only, not external. For the internal water supply, installing, testing, and commissioning approved make of STR 11 CPVC pipe we are using. CPVC pipe we are using for the water supply and fitting conforming to ASTM D28416 with special switches, C, elbow, checknut, union, flanges, nipples, etc., including cutting, fixing in on walls, ceiling, etc., as per drawing. The quoted rate sulfur include for necessary chasing of the wall, making bore in the walls, and making put the chased surfaces and put in the cement mortar, etc. complete. So while installing the pipe, they required some wall hole. In the wall, some bore also required. So that bore also the vendor need to put, vendor only have to do. After making the bore, after installing the pipe, they have to seal the bore. So that only we have mentioned here. We are mentioned here, seal and wall sealing, etc. As per drawing. After sealing bore walls and making wood the chased surface and bores in cement mortar, etc. After the completion of work, they have to fill the cement mortar to finish the surface. Everything they have mentioned here. All the things mentioned. So then we have to code, the vendor have to code the all the things the vendor have to consider after the vendor have to quote for running meter. So here it is starting pipe size is starting 15 mm to 50 mm, 15 mm to 50 mm, 15, 20, 25, 35, 40. This is the market available size. They have to quote. We have to put the running meter and the rate and everything we have to put. If you are not using 50 mm, 40 mm means you have to put RO. That's the rate only we have to put. That's all. And the CPVC pipes. This is the SWR 11 pipe CPVC pipe. This CPVC pipe is schedule 40 pipe. The schedule 40 pipe is for the schedule 40 pipe. We are putting all the description. From the 30 ohm it is starting. 30 ohm it is starting. So all the things we are putting, but quantity and all. And the supply installation and testing approved method ball walls. This is the ball wall. For the ball wall we are putting. For the ball wall is confirmed to IS 1702 with union etc. complete. It is starting from 20 mm to 50 mm. Ball wall is starting from 20 mm to 50 mm. All the ball walls are screw end only. 20 mm also screw end only, not flange end. So how much is that and all we have to put it here. The rate also you have to put it. Supply installation facility commissioning of butterfly valve. Butterfly valve after the 50 mm we have to use 60 butterfly valve only. That butterfly valve is conforming with the IS 13039. With the standard we have to put it. With the necessary connection fitting like flanges, nuts and bolt etc. complete, they have to supply. From the 60 mm to 150 mm we have to put butterfly valve based on the your project requirement. Your project is more size, large size means some 300 also will come. And if you go the another thing, pressure reducing valve, supply installation testing and consider approved make gunmetal GM pressure reducing valve, gunmetal pressure reducing valve, conform to relevant standard with union bolt stainless pressure pressure graduation etc. Pressure graduation means regulation. Pressure regulation is a complete fitting. 100 mm dia, 50 mm dia, so 80 mm dia, 50 mm dia they are using. So that rails also here we have approximately we have. And the automatic air release valve. Automatic air release valve also we have to put. And after that, supply and installation precast PCC support brackets. To 1:2 is concrete missing of size giving below pipe support. For the pipe support in the terrace area and some site area above ground pipe is where the above ground pipe is coming. In that area we are using concrete, cement concrete pedestal also. But in our plumbing people will not put the concrete work and all, but we have to show the some cubic meter of concrete for the pipe supports. We have to give in our PF. That also approximately we are giving for 50 mm, 150 mm into 150 mm into 150 mm height. See, this much numbers are required. 230 mm, 230 mm into 150 height, 10 numbers are required. Maybe this is coming in the pump room. I think this is coming into the pump room area. They are given. And then overhead water tank. Supply and fixing distinct inlet and outlet vent and overflow pipes fitting with the CA frame and the cover to the water tank, underground water tank, storm water collection sump, etc. Complete with the step parcel in the drawing, etc. Water tank, less fittings. What are the things we will put into the water tank? That only. Approximate depth is 2 meter water tank. 6 number CA manual we have to manual for the manual water tank and underground tank we have to put manuals that quantity only. And 2 numbers of puddle flange, inlet puddle flange 60 km dia, 2 numbers of outlet puddle flange 150 km dia, like that puddle flange for connecting the pipes. Vent pipe, 6 numbers of vent pipe, 2 numbers of overflow, 2 numbers, and one AL step ladder, aluminum step ladder for the water tank. If you want to put grow the water tank, you have to use the ladder and all. So that only aluminum ladder they have put. 3 numbers of drain pipe puddle flange, drain pipe puddle flange. 3 numbers for 50 dia. Sleeves for level controller, for the level controller, sleeves and all they have put. All puddle flanges are to be hard tipped galvanized. The notes also they have to put all the puddle flanges. So these are the things they have given for lump sum amount. These are the things 1 unit they are considered 1 set. So 1 set 45,000 they have put. That approximate rate only. The vendor will quote separately. All the things they will analyze, they will quote some variable cost. So like that is this is the water supply unit. Drainage and the water supply we are completed. After that, basement stormwater drain. In the basement, if you have the basement in your project means you have to put the basement drain also. For the basement drain, supply, fixing and testing inlet and outlet pipes after putting to the stormwater collection sump with the PVC steps are shown in the drawing. Complete if necessary. Like that, you have to put all the things. Approximately that you put depth also you have to put. For that, 1 number of 100 mm dia puddle flange for vent pipe, mosquito proof mesh. This is for vent pipe. Mosquito proof mesh you have to use. 1 number of 80 dia puddle flange for the outlet pipe. 1 number of 600 decision manual for the cover, manual cover. Everything they have for the stormwater collection sump. The cost is 1 set cost is 16,000 they have. For the stormwater submersible pump, stormwater submersible pumps for adequate supply and fixing testing commission for stormwater submersible pumps of adequate HCP capable of giving a required discharge at a suitable head to work on 3-phase 3 phase 50 gets 400 to 450 watts with necessary unit plungers. To 1:2:4 etc. complete with the wiring frame TPN, switch on off control panel etc. Or one standby, working on standby. These are the things for the storm water submersible pump or the storm water supplement system. These are things we have to give the necessary fittings we have to give. That only they have to do. For the dewatering pump, supply fixing, testing and commissioning the dewatering submersible pump of adequate HP. These are things you have to put. So after the supply and installation of MS fabric ramp train grating. Under the ramp, you have to put the ramp train also for the distribution they have to pay. End of the ramp, you have to put the ramp train also for the grating and all. Description they are given 80 mm to 80 mm. It is 8 mm. The coated red shall be good for the painting to coat of enamel print over coat of the premier etc. Complete without the rim 600 mm like that they have to do. This is the grating of the ramp train. SS grading heavy duty supply and fixing testing pipe bend and are shown in the drawing with the 200 into 200 SS grading heavy duty pipe bend with the grating. We are using for the basement drain. This we are using for the basement drain. Pipe bend by 100 mm, 110 mm, 70 mm, two types they have put. These are the basement drain we are going to use for the inside the basement. We are using these are the things. That and all we are using. If you have basement in your project, you have to give this necessary item. You don't have basement, this you don't give. These are the external water supply system. Other than building, excavation in all type of soil for laying water supply pipes up to fundamental dia, including forming bottom faces to record level, refilling selected examined earth around the piping layer, 100 mm, 110 mm thick. Watering, consolidating, and dispensing of the surplus earth with the site within the site as directed by the site engineer with a lead of 2 meter complete depth up to 2.5 meter below ground level. Now this is the excavation trench. Excavation of trench to lay the pipe, like they have mentioned quantity of the excavation. Digging the trench cost they have to pay. For the trench they have given the specification. So installation of pipe 100 mm dia pipe they are going to install. The supply installation testing the commissioning of approved medium quality cost B class B GA pipe, class B GA pipe and fitting conform with IS 1239 PA and PII malleable malleable vessels such as T elbows, checknetting unit branches, nipples, etc., including cutting, soldering, fixing below ground pipe or above ground pipe, everything. This is the GA pipe, class B pipe specification. 50 mm to 150 mm they are using. So that rate also they have to do. And the GM non-return valve, this may be used in the pump room only. GM non-return, gunmetal non-return valve, we are going to use pumping. CI flange brass Weissteiner. This is the Weissteiner you are going to use in pump room only. And the municipal water supply main connection. Municipal water supply for the municipal getting the municipal water supply connection for lump sum amount 30,000 they have put in. Walls of construction of wall chamber. How the water supply walls chamber how the specification the cover everything they have to 10,000 per chamber. Water meter for the municipal water connection. Water meter also we have to put that things we have to put like this. Digital level indicator, water indicator, level indicator. And the hydrodynamic system, pump, supply, fixing, testing, and commission path, Variable speed hydropneumatic system. This is the pump of hydropneumatic pump. The system shall comprise of three numbers of two working and one shall be pumping. Recharged pressure tank, pressure switch, etc. Complete with the electric motor, 2,900 RPM. Like that, they have put this and all. You don't want to put this RPM belts and all. You don't want to put, but this diamonds little bit. So like that you have to put. Underground water tank specifications. How the underground water tank. And the external flow motor, for the external flow motor drain also excavation and all the start of soil layer, RCC pump, everything they have to do. The RCC pipe, RCC NP pipe joint specification. Catch basin or the catch basin, this is the specification. Rainwater harvesting stump, rainwater harvesting submersible pump. So like that. Here we have another one BAQ also is there without weight and all. I will show that also. VAQ for the plumbing system. Client name. This is the exact VAQ actually. Client will ask like this only. After you are doing this VAQ, they will put into the vendor. The vendor will only quote against the VAQ quantity and the specification. Client name or project name, tile coating and project number. This is our company name. This is client client logo like that is sir. Serial number, description, unit, total quantity in region 0. In the region 0 like that, total quantity in region 1 like that. Some of the variation will come means after that they will raise quantity like that will be there. Here we will not put any rate here. That's only rate quantity only will put. All the specification we will put here, size, pipe specification size, and the running meter, how much running meter is there coming, like that only we will put. So for valve also, for AGM valve, that is standard, everything we will put it. This is here, all things we will put into this quantity only. This specification only we will give. For the supply installation testing, we have CP health password, for the health password we are giving. Tap, CP chrome plated tap, Bibcock, operation mixer tap, 50 ml CP basin mixer tap, sink mixer, bath diverter shower for the shower, bath diverter, the shower fixing everything, water heater, ceiling motor water heater, electric water heater. So variable electric water heater size is variable size it is coming. So 30 liter, 15 liter, like 6 liter, and 3 liter is there. So 3 to 30 liter we are using. 3 for wash basin users, 6 also for wash basin only. So all the models, loading and unloading area we are using. The 6 liter male and female toilet operation area, admin building toilet we are using for the wash basin. This 50 liter canteen building, pantry, male and female toilets wash area we are using 50 These are we are using. Remember, this is cattle liters. Canteen building, male and female shower area, change room. We are using cattle liters. We are using. All things we are given here. Internal toilet sewage gravity. Supply EPC pipe. SWR pipe 82 mm, 110 mm. We are using. This PAK we are preparing for the Iran project. So that's a 82 mm dia we are used. And EPC pipe, diesel multi-flow drop, PVC multi-flow drop, PVC fundamental PVC drop, 80 mm PVC floor clean out, everything we are using. 110 mm floor cleaned out. National sewage gravity system, 1 mm dia pipe, HDP pipe only we are using. That standard also is there. Instead of UPC, we are using HDP pipe, HDP pipe. So 160 200 we are using. Supply installation just to consider RCC N2 to 25 RCC pipe we are using. For the quantity also we are using. Like that is the for every discipline we are for fire system also. This is a fire pipe. For the pipe, how fire system, how the pipe size we are around that knowledge there. OSL white type gate wall everything we have to do. These are the fire, just quantity only we are giving. This is the mechanical giving. What are the pipes and everything we are giving. This is the only quantity description and quantity specification and the quantity. That's all. That only we are giving. Mechanical pipe work this is. So in this fire equipment everything we are giving. White type strainer, automatic airways, watering valve, everything. Just quantity, description, quantity, that's all. So fire extinguisher, fire extinguisher, everything is there. So this is the plumbing unit, like that. So two type of BOP is there. Only quantity, description, specification, quantity, that's all without rate. Another one is description, specification, quantity with the rate. Feature. Two type of villa quantity is there. Which one is required for the project? That model we can prepare and give. Cover sheet also is there. This is the cover sheet. Cover sheet. This is the cover sheet. Villa quantities or mechanical piping works. The revision everything there like this. Summary. This is the summary. Summary of all the vehicle or mechanical system. This is summary. Based on this one, they will purchase. Like that is that. So this may be very according to your requirement. This is the model only based on your requirement, your company, what type of company you are going to join. If you are working for the contractor, that format will be different. Contractor vendor will put the exact rate. Consultant will put the approximate rate only. Client also will put approximate rate only for the estimating the project value. The exact rate they will make some 20% plus or minus 20%, they will keep the budgeting. So like that is the, so based on that requirement only you have to put for the vehicle. The sample vehicle now I will share you. For the sample for reference purpose you will keep that now. If you have any doubt in the vehicle, you can also ask.
Sir, can you share the PPTs for the previous classes, sir? We didn't receive the PPT for the last two classes.
Okay. Now I will share all
Yeah, we have
things.
received up to water demand calculation, sir, that 23 serial number. Up to that, we have received PPT.
Okay. I will share.
Okay, sir. Okay, sir.
Okay, thank you.
Okay.